chapter 4, number 15. It says, a small 8-kilogram rocket burns fuel that exerts a time-varying upward force on the rocket. Assume constant mass as the rocket moves upward from the launch pad. This force obeys the equation F equals A plus BT squared. So, we're going to keep that in mind. F equals A plus BT. Measurements show that at T equals 0, the force is 100 newtons. So when T equals 0, F equals, and at the end of the first 2 seconds, it is 150 newtons. So when T equals 2, F equals 150 newtons. Part A says find the constants A and B, including their SI units. So we'll start with part A. So for part A, we're just going to plug these into the equation to solve. So if T equals 0, then we're saying like F of 0 equals A plus B times 0 squared, which anything times 0 is 0. So A is going to equal F of 0. F of 0 is 100 newtons. So we know that A equals 100 newtons. And then now that we know what A is, we can solve for B using these values. So then F of 2 will equal A, or 100 newtons, plus B times 2 squared. And then we know, again, the F of 2, when time equals 2, F is going to equal 150. So we have 150 newtons equals 100 newtons plus B times 4. We can subtract this over. That's 100 newtons, so we get 50 newtons equals 4B, and 4, this is important because we want the SI units. So we know that this is time in seconds. This is in seconds. This is seconds. This is seconds. Squared. So, sorry, that's the key part. So then when this gets squared, the S is also squared. So 4B seconds squared. So then when we divide 50 newtons by 4 seconds squared, we're going to end up with B equals 12.5 newtons per second squared. Their SI units. So that was all part A. Let's see if we can fit part B on this board too. I'll draw small. So then for part B, it wants to know, find the net force on this rocket and its acceleration, and then B has 2 parts as well. So I is the instant after the fuel ignites, and II is 3 seconds after the fuel ignites. So this is all going to be part B, and this will be part I. So our equation, now this equation becomes F equals 100 newtons plus B, which is 12.5 newtons per second squared. Squared. Sorry. So for part I, it wants to know what it is right after it launches. So I just plugged in 0.01, and that worked for me. So force is going to equal 100. I'm going to leave off the SI units for now just to save time. 100 plus 12.5 times 0.01 squared. Which, when you plug that in, you're going to get like F equals 100.00125, and that will be newtons. from like the rocket, but then you've also got gravity pulling on it as well as it takes off. And so we're going to solve for gravity, which the force of gravity is going to equal the mass times the acceleration of gravity. So gravity is going to equal the mass, which it told us at the beginning was 8, I believe. Yeah. So it's going to be 8 kilograms times gravity, which is 9.81 meters per second squared, which is going to give us 78.48. Now, if this is the force of the rocket taking off, so in the positive direction, and this is gravity pulling in the negative direction, we're going to take the 100, we can go all the way out if we want, 1.5 minus 78.48, which will give us 21.52 newtons. So that's our net force, both forces acting on it together, is 28.5, and if we go to the correct sig figs, we'll just have 21.5 newtons. And then it also wants the acceleration. So if force equals mass times acceleration, according to Newton's second law, then acceleration equals force divided by mass. So we're going to take our 21, we'll just plug that in. A is going to equal 21.5 divided by the mass, which was 8. So our acceleration will equal 2.70 meters per second squared. So that's part B. Part I. I'm going to go ahead and erase this first side here to do I. We can erase all of that, I believe. Okay. So we're gonna do this exact same thing that we did over here, but we're gonna plug in 3. So force is going to equal 100. Here, I'll draw a line so we don't get confused. 100 plus 12.5 times 3 squared, which is going to equal 212.5. Which, if you round, is 213 newtons to get to the proper sig figs. And then we already know this. Our G is the 78.48, so we can just go ahead and subtract 78.48 from that, and we're going to get 134. That's the force acting on it, the net force, and then the acceleration again is just going to be that net force divided by the mass, which is going to equal 16. Cool. Okay, now one last part, part C, is really easy. I'll just erase this bottom chunk here, and we can do it down here. So part C just wants to know, it says, suppose that you were using this rocket in outer space far from all gravity, what would the acceleration be 3 seconds after fuel ignition? So this is going to be this same question basically, but we're not going to subtract gravity from it before we find acceleration. So we're going to take this answer, the 213, and just divide that by the mass, which is 8, which should give us approximately 26.6 meters per second squared.